This man built the most precisely aligned structure on Earth 4,500 years ago with a copper chisel and a piece of string. 3 seconds ago, he watched a machine pour concrete by itself, and he didn't even blink. Over the next 10 minutes, I'm going to hand him carbon fiber that's stronger than steel, put him under a crane that lifts more than his entire workforce could in a week, show him a skyscraper designed start to finish on a glowing rectangle, and he's going to look at all of it unimpressed. Not because he doesn't understand it, because he understands something about it that we don't. By the end of this video, he asks me one quiet question I still can't answer. I'll tell you what it was, but you have to see what breaks him first. My biggest achievement this week was assembling a flat pack desk with no leftover screws. His was a structure that's still standing after 4,500 years. Let's see what he makes of what we've done since. Quick rewind. Because 3 weeks ago, I had no plans to pull anyone out of ancient Egypt. It started with a rabbit hole about modern construction, and one fact I could not get past. The Great Pyramid of Giza is still the most precisely aligned large structure ever built. Its 4 corners face true north, south, east, and west, with a margin of error of 1/15 of a degree. 1/15 of a degree. You know what we allow a modern build? Up to 1/2 inch of drift per floor, and we still get it wrong. His version was finished around 2500 BCE. Copper tools, wooden sledges, human hands. No wheel for transport, no iron, no pulleys as we'd recognize them. My version has AI that spits out a full architectural blueprint in 11 seconds. And somehow, his building is the one still standing. So, I signed an NDA with myself, used a temporal bridge I'm legally not going to explain, and went and got the man who ran the whole thing. Meet Amenhotep, Master Overseer of Pyramid Construction, Old Kingdom, Egypt. I thought I was bringing him here to be amazed. Keep that thought, because the first thing he reacted to wasn't anything I expected, and it set the tone for the entire day. First stop wasn't a landmark, wasn't a skyscraper, wasn't anything that photographs well. I took him to an active construction site. I wanted to watch his face the moment he saw how we build now. And the first thing he reacted to wasn't the cranes. It wasn't the machinery or the size of the thing going up. It was the noise. In his world, the sound of construction was human. 20,000 people calling out, hauling, coordinating across a site. Organized chaos that somehow produced perfection. Here, jackhammers, concrete mixers, hydraulic compressors, steel screaming as it's cut, all of it at once. He put his hands over his ears and looked at me like I'd walked him into the apocalypse. Then he looked up at the building, and he went quiet. Not overwhelmed quiet, studying quiet. He started counting, floors I think. Then he scanned the skyline, then back to the site. Then he pointed at the building, swept his arm across everything around it, and gave me a look I couldn't read yet. I'll come back to that look because it took me the rest of the day to understand what he was asking. But the short version is this. He'd spotted something in the first 90 seconds that most people never notice at all. He was asking why they all look the same. And I didn't have an answer because he was right. Glass, steel, rectangle, interchangeable. 1,000 buildings you could copy and paste. In his world, every structure was different. Every surface told a story. Every stone was placed on purpose. A 4,500-year-old man clocked something about modern architecture that takes most critics a career to put into words. Then he saw the crane. And this one stopped him cold. Tower crane, 200 feet up. One operator in a glass cab at the very top, swinging 15-ton steel beams around like they weighed nothing. Amenhotep watched it for 3 full minutes without moving a muscle. I told him, one person controls all of it from up there. He asked, through the increasingly sophisticated sign language we'd been inventing all morning, how heavy the load was. I looked it up. Around 15 tons for that beam. He held up his fingers and started doing math. And here's why that matters. Moving a single 2.5-ton limestone block took roughly 20 men, wooden sledges, and wet sand poured ahead of the runners to cut the friction. That's one block. There are 2.3 million blocks in the Great Pyramid. He ran that calculation every single day for 20 years. And now he's watching one guy in a chair move 6 times that weight before lunch. I braced for the defeated look, the envy, the moment it finally lands on him how far behind his world was. It never came. Instead, he pointed up at the cab, then down at the ground, then spread his hands across the whole site and asked me a question I genuinely couldn't decode at first. Hold that question for 1 second, because the answer is the entire point of this segment. He was asking, can that man up there see everything? I said, no, not everything. He's got radios. People on the ground signal him what he can't see. Amenhotep nodded slowly. Then he pointed at himself and swept his arm across an imaginary horizon. He was telling me, I could see my entire site, every worker, every block, every problem, all at once. The crane operator is more powerful than anything Amenhotep ever had. But Amenhotep had one thing the operator will never have: total awareness. I'd never thought about it that way until he showed me, and it wouldn't be the last time he did that today. The materials test was next, and that's where he really surprised me. I wanted to show him what we actually build with now, things he couldn't have dreamed of. So I got samples, real ones. Carbon fiber, stronger than steel at a fraction of the weight. Aerogel insulation, looks like frozen smoke, holds 4,000 times its own weight. And self-healing concrete. It has bacteria living inside it that produce limestone when a crack forms. The material literally repairs itself. I laid it all out and let him examine each one, and he went straight for the self-healing concrete and stayed there the longest. He kept snapping off a small piece, holding it to the light, then looking back at me. I explained it as best I could. Bacteria, limestone, heals itself. Then he pointed at the concrete, pointed off toward where Egypt would be, and raised his eyebrows. The question was obvious. Does this last as long as what I built? And the honest answer stopped me. Because we don't know. Self-healing concrete is maybe 30 years old. It hasn't faced 4,500 years of earthquakes, erosion, and collapse. I said, we think so. He set the sample down, very carefully. Then he picked up the carbon fiber, bent it, tried to snap it, couldn't, and looked genuinely surprised. He pointed at the building going up. I nodded. Yeah, that's what it's made of. He held the carbon fiber in one hand and looked at his other hand, the one that spent decades on limestone. Then he set it down too. Not dismissively, carefully, almost respectfully. This man knew quality the second he held it. He just wasn't convinced we'd earned it yet. And then I made a mistake. I showed him how we design these buildings in the first place. I pulled up BIM software on a laptop. Building Information Modeling, the tool engineers use to map every pipe, every wire, every load-bearing wall before anyone breaks ground. You can rotate it, zoom in, click any beam and see what it's made of, what it weighs, what forces are pulling on it. He leaned right in, actually fascinated. I showed him a full skyscraper, every floor, every system, all of it modeled before a shovel hits dirt. He pointed at the screen, then at his own head. I said, "Yeah, this used to live inside someone's skull. Now it lives in here." He thought about that for a long moment. Then he pointed at the screen again, then out at the real construction site. And then he made a slow, crumbling gesture with both hands. I said, "What do you mean?" He did it again. Building on screen, building outside, then crumbling. And I think I finally understood what he was getting at, and it's been bothering me ever since. He was asking what happens when the software is gone, because the pyramid has no blueprint, no file, no server. The knowledge of how it was built is baked into the stone itself, the angles, the load paths, the math. Any engineer alive can stand in front of it and reverse engineer the whole thing from what's physically there. If every copy of our design software vanished overnight, a frightening amount of what we've built becomes a mystery. He didn't say "I told you so." He didn't have to. And then I took him to the one thing I was actually proud to show him, which is where the day stopped being funny. I took him to a finished building, a new one, glass facade, 40 stories, opened 6 months ago. Genuinely beautiful. I wanted him to see we get things right, too. He looked at it the way you look at something when you're hunting for the right words. Then he walked up, put his hand flat against the glass, and his face went confused. Not at the glass, at what was missing from it. Here's the thing I'd learned going down this rabbit hole. Egyptian construction wasn't only engineering. Every surface meant something. The hieroglyphs weren't decoration, they were records. Who built this? When? For whom? What it cost? Who died making it? Their walls were a permanent, weatherproof hard drive of an entire civilization. He pulled his hand back from the glass, looked at me, and swept his palms slowly across that smooth, blank, perfect surface. No story, no record, no mark. We build bigger, we build faster, we build smarter, with materials he couldn't have imagined. But we stopped writing on the walls. We stopped leaving a record that doesn't live on a server somewhere. We stopped building things that tell you who we were just by looking at them. His buildings are history lessons. Ours are lease agreements. I didn't have anything to say to that. A man from 2500 BCE had just diagnosed something about modern construction that critics spend whole careers circling. We've optimized everything except meaning. It's time to send him back to a world with no power tools, no safety codes, no climate-controlled site office with bad coffee. He's stood under a tower crane, held carbon fiber, watched a skyscraper get designed in real time on a sheet of glowing glass. But that's not what he's taking home with him. He's taking a question. The one he kept asking all day in a dozen different forms. The one I promised you at the very start. Will it last? Not, will the building stand up? That's an engineering question, and we're good at those now. He meant, will it last? Will it mean something in 500 years? Will anyone look at it and understand who we were? Will it tell the truth about us? Because in his world, that wasn't a bonus feature. That was the entire point. He's gone now, back to the desert, the copper chisels, the impossible logistics problem he somehow solved without a single computer. And I'm standing here in 2026, surrounded by the most advanced construction technology in human history, wondering if any of it will be standing long enough to matter. 4,500 years later, people are still studying what Amenhotep built. So here's the question I'll leave you with. What are we building right now that anyone will still be studying in the year 6,500? I brought a pyramid builder to 2026, and all he did was quietly ask whether we build things worth remembering. I still don't think we've answered him. If this one got you thinking, hit that like button. It moves the algorithm more than you'd believe. And subscribe, because apparently the algorithm is harder to shift than a 70-ton granite block.